All right, this problem's pretty tricky, I think. Maybe hit pause and read through it. So this Mr. Starnes likes sugar in his tea, and I guess he has it figured out that he typically needs 8.5 to 9 grams of sugar in his tea for it to taste right. He adds 4 packets one day to his tea. Is that enough? He conveniently finds out that 1 packet follows a normal distribution. So you could do something like this. 1 packet equals X, which is normal, and it follows a mean of 2.17 and standard deviation of 0.08. We want the probability just very simple, that his tea tastes right. So I need a function for total packets. And it would be so tempting to write 4x. It seems like it would be a very simple way of writing it, but we need to write it even simpler, all because of standard deviation. So first of all, the question, probability, is that his tea has between 8.5 and 9 grams of sugar. That's the question right there. He has 4 packets, so let's write them independently of each other, because I think we can assume that each packet is independent. It's kind of like a random sample. 1 packet probably doesn't dictate the amount of sugar in the other packet. And if we write our function like this, it's going to work. It looks tempting to write 4x, but that's going to change standard deviation. Remember, if I write 4x, think of your algebra properties. If I write 4x and I square everything, I'm going to have 16 sigma squared. Whereas if I write it like this, I'm going to have sigma squared 4 times, and that 4 hasn't been squared. It's just 4 sigma squareds. And if you don't believe me, try it out. Write 4x, square everything here, and you're going to get a different result. So sigma t, or actually let's do the mean first. We usually start with the mean. 2.17, and yes, the mean is 4 times 2.17, but I'm going to write it like this since I have it like this. So that gives me 8.68. Standard deviation is 0.08 squared 4 times. And that is 0.16. Since x was normal, t is normal. And now we're ready to go. Find the z-score of 8.5, because it's a normal distribution, remember? And I get negative 1.125, z-score of 9. We could do that one in our head, right? 0.32 divided by 0.16. Final answer, normal CDF, negative 1.125 up to 2 is 8470. Very tricky problem. Also reason to write your work, because if you accidentally did 4x, you would end up with 0.32 for your standard deviation, and that would completely change the answer. But all they would do is dock you on the distribution. They wouldn't dock you for anything else. So you'd still get a lot of points. Show your work, please. All right, see y'all later. Bye.